Today we are going to start to talk about density. All right, now, this is going to fit into what we've been doing because it includes both the math portion, working with the units, as well as with graphs. All right, so what is density? As you remember from your previous experience, all right, somebody says that you are dense. Is that a nice thing? Could mean you're heavy, right? But there's another reason why people use it. You're kind of stupid, right? Right. Now, the reason why that's a term of, I guess, being nasty to somebody about their intelligence or their ability to learn is because that's like saying that someone's thick-headed, their head is dense, and nothing gets in there, right? So, what density is all about is how much matter is going to be jammed into whatever space is available. So if something is really dense, that means that a small amount of it can be really heavy. Right? A good example of something that's really dense are actually these tabletops here. These tabletops are very dense because they are supposed to be chemical resistant, and they are. They've been around for a while. And burn resistant, you can like put stuff on, put alcohol and stuff on, set it on fire, and it doesn't burn. Right? We're not going to do that, but you could do it, and it wouldn't burn the tabletop. Right? But about 80 to 90% of the weight of these tables is all in this tabletop. Right? Very dense material that makes it very heavy. Right? When it's not dense is like when you get a package and you get the big pieces of styrofoam. They're like huge, and you can just kind of throw them up in the air because they're so light, even if they're really big. Right? That's very little mass and a lot of volume. So that makes it have a small density. Mathematically, then density is this. Is mass divided by volume. Okay. So the mass of the substance divided by its volume will be the density of the material. Now, graphically, as you see here, we're going to put the mass on the y, and the x-axis will have the volume. So that means which of these two is the independent variable? So volume is independent. Okay? Meaning that typically in density experiments, you're going to pick how much of the substance you're going to use to figure out its density, and you'll pick it out by how big it is, i.e. its volume. All right? So here's a good sample of this. All right, so let's take a little scenario here. Let's say that we come in today and we decide, I don't know, to take Elena's tabletop here, Elena Alex's tabletop. We just take it off, we just smash it up in the parts, and then everybody measures the mass, and then somehow comes up with the volume, and then gets the density, right? And then this is the resultant data of that little experiment. All right. Now, what does this graph tell us? Well, the point of putting these things on the x and the y axes and keeping track of that is, all right, here's where that math class comes in here and hangs out with us in science. So, all right, we're going to use our math knowledge. The slope of a line. How do you find the slope of a line? Huh? Rise over run, right? And rise is which axis? The y, and run is the x, right? So if you're going to find a slope, then you're going to do y2 minus y1 divided by x2 minus x1. Does that look familiar, everybody? Right? That look familiar, Evan? Got it? All right, good. So then in this case, y equals which of these two values, mass or volume? The mass. And x is volume, and That means the slope of this line is the what? See the connection between those two? Between this right here and this right here? So then the slope is the density. When you make this graph, you find the slope of the line, that's the density of the substance. Right? And that's why, again, that's the standard way to do density plots, because once it happens, then that slope of the line is going to be the density. Now, does this slope change throughout the experiment? Right? What does this tell us about the density of our pieces of tabletop? They're all about the same, right? Because it's a consistent slope. Did you not say the same, Willie? Okay. We'll just assume you said the same, right? Okay, so that tells us that the density is consistent throughout. And that's a good thing, because it's a characteristic of substances is that they have the same density regardless of how much of it you have. It doesn't change, right? So when you increase the mass of the volume, then the other one increases as well, and it stays to be about the same, right? They're not perfect. You have the dots are some of them are above, some of them are below. We get the line of best fit. You guys have heard that before? Yes? Right? From math? We have the same number of dots above the line as below. That means that's the kind of the estimation of the data, right? And that's what we want. We want one nice little line going on there. We don't want to have a bunch of different ones, right? So if you get this data, then you are not going to connect the dots with it. You're going to find a line of best fit. Right? That's going to be a consistent thing when we do experiments in here and in any science, is that you always want to look for that kind of the general trend of the data rather than looking at each individual point. All right. Now, we also have this down here. Why does it say that student needs help? Because it's not right. Well, how do you know it's not right? It's nowhere near the line. So we look at that and we say, well, maybe the student took his or her mass wrong, didn't read the volume correctly, something, right? But either that or for some reason they didn't have the same substance as everyone else, because it all should be right around that line. Okay, so the slope of this line is the density, and if we want to find the density, that's what we do, is we use that slope. One of the big pictures points there. So going back to our slides over here, that's what this is telling you down here. Okay? As the slope represents the density. Okay, now, oh yeah, and remember this too. This will be important. Remember, the slope is the steepness of the line. Okay? All right. Now, we just stated why this is the case. It should be perfectly straight because the density doesn't change. So the curve of the line should not change. It should be one consistent slope throughout if you're properly measuring density. Now, here's another one that's important that you want to look for to see how good the data is. That it passes through the origin. Why is it important that it passes through the origin? Well, when we use graphs, one thing to understand is that when one of the two variables, either the x or the y, is 0, it's almost always significant. It's always something that tells us about the data, about what we're studying. Why do we want this to pass through the origin? And so why, like if, let's say, volume is 0, we don't want to have a value on that y-axis. What would that say? Well, I would say we have no volume, we have no anything, but yet it has mass, and that doesn't make sense. right? If it doesn't have volume, that means there's nothing in existence, but if it has mass, that doesn't really make sense. And the opposite is true too. If it doesn't have mass, it shouldn't have volume. So when mass or volume is 0, then the other one should definitely be 0. So the better data sets are going to have it passing through the origin. Right? And this one, the line of best fit easily goes through the origin, so that makes us happy. Won't always be the case. And what that tells you, though, is if there is some error in your measurements. And if you're actually doing real research, then what that would usually mean is that you have to redo it. You have to do something else again. Okay? So, let's move forward with this. All right. So if those two are the case, if it's perfectly straight, then you can go ahead and take any point on that line and divide the y and the x value and get the exact density, and it should be the same throughout the line. All right? Okay? Questions on that? Everybody follow me so far? Nothing too crazy there. We're just taking you've done all these years of trying to learn all this math stuff, and now we're going to take it in here, and we're going to try to do something with it and try to understand the science better using all that stuff that you've done, working with slope and the equation of the line, which we'll be doing later too, the y equals mx plus b stuff, and making sense of it physically. All right? Okay, now, here's something, and by the way, this is something, if you're a student, this just screams to you that this will be great questions, right? You have two different lines and they're different slopes. What does that tell you?